Hmm. Okay, we are live. If there is anybody in the chat section, please let me know if I am properly audible and visible to all of you. Just let me know in the chat section, guys. Okay, yeah. Just let me know, guys, if I am properly audible and visible to all of you. Just give me a quick thumbs up in the chat section. Okay, thanks, Keshav. Uh, Okay, thank you guys. So, guys, in this series, we are bringing this series, and in this series, we are going to discuss complete end-to-end machine learning for your GATE data science exam. So, we'll start with in today's session, introduction to machine learning, and we'll discuss some topics regarding linear regression, right? So, we are going to work on linear regression in this session, and these sessions will be on Wednesday, Friday, and Saturday at 5 p.m. So be available, and if your colleagues or your friends require these lectures, just share that playlist link with them as well. If you are not available for the live session, you can also look for the recorded session. Okay, but I'll suggest that be in live session so that you can ask your doubt and all other things. Okay, so I hope everything is perfect, right? Let's start our session. So first is introduction to machine learning. Just want to know one thing, that what is machine learning? What do you understand by machine learning? Just let me know, guys, in the chat section. What do you think about machine learning? So if I talk about, first, let me just give you a basic about GATE data science subjects, right? So if I'll see, I have 5 subjects in the, I have 7 subjects, right? First we have calculus, linear algebra, and then we have probability and statistics, right? Probability and statistics. We have this in GATE data science. Then we have machine learning, and then we have artificial intelligence, and then we have DBMS, and then we have DSA in Python, right? So now you can see that these 3 subjects are of mathematics, right? So mathematics is important, and machine learning is also little bit dependent on mathematics. Then we have AI, DBMS, and DSA in Python. So if you are from computer science branch, you already know DSA, and if you will see previous year paper and previous year sample paper, you would find out that DSA in Python is really easy in the paper, so you can easily do it. So main thing, you have to work on this mathematics and MLAI section, right? Right, so we have to work on this. So that's why I'm bringing this machine learning series, and later on we are going to start the series on calculus, linear algebra, probability, and statistics. So you would get all the lectures here, and you can easily work on all the topics of GATE data science. Okay, so first is introduction to machine learning, right? I asked one question, that what is machine learning, and some of the students have answered. Yeah, correct, guys. Okay, machine which work automatically, making machine work automatically, giving instruction to the machine which coding explicitly, and data points, right? Correct answer. So that means machine learning is a science of programming computer, so they can learn from the data. So what will we do? We'll feed some data to a machine, and then with respect to that, with giving some coding, we are going to combine those two and we are going to get output, right? We are going to make machine thinks using machine learning, right? So which a human can do, um, we are going to do with the machines, right? So there are several examples like email filtering, right? Spam filtering. So let's suppose you get a mail, right? Now you have to identify that this mail is a spam mail or non-spam. If you would read an email, you would understand that is it a spam or it is not spam, right? But I want to just, because in a day any person gets a number of emails, so it would be really difficult for anyone to go through each of the mail and then classify, right? So that's why we'll feed some of the emails. So I'll give number of emails to a machine and specify that these emails are spam and these mails are non-spam, right? Non-spam emails. So then what machine would do? Machine would find a pattern that what kind of spam emails looks like, right? So in spam emails there are lot of big numbers, right? In spam emails there are spelling mistakes. So these things machine is going to find out and then it is going to classify that a particular mail is spam or not spam. Okay, we'll try to do that as well. Sadia, right now it is on YouTube, right? Right, it is what it starts from a question that can machine thinks, right guys? So machine learning is a science of programming computers so that they can learn from the data, right? So we'll provide some data and we'll say that machine is going to make their decision by themselves. We are not going to do anything in that. So if I'll talk about general definition, machine learning is a field of study that gives computer the ability to learn without being explicitly programmed. So for particular email, I'm not going to check. For every particular email, I'm not going to check. I am just I have just given the algorithm, I have just given the previous data. Based on that, machine trained itself, and then after training I got to know that for different mails that these are spam or these are not spam, right? This is one of the example. We are going to discuss so many example in these sessions. Okay, so that is machine learning. So machine learning basics are clear, that we are going to provide information to the machine, so that information to the machine so that machine can work properly. It's like if I am feeding information to a baby, right? So what would happen if I say that that the color is blue, right? So the baby would remember that the color is blue, this color is blue, something like that. So we are going to do that with the machine, right? So these are examples of machine learning. So I already told you spam email filtering, in which we are going to classify that a particular mail is spam or not. Anomaly detection. So anomaly detection is finding out that is there any fraud or any outlier in my data set or not. So it is usually gets used in banking sector, right? What would happen, let's suppose a person is doing transaction of in lakhs, but sometimes there is one transaction which is too high. Let's suppose usually he is doing transaction around 1 lakh or 5 lakh, up to that, but some at a certain point there is a transaction of 80 lakhs. So what would bank would do? Bank would detect that anomaly, right? That is anomaly, that is an outlier. It usually doesn't happen with a particular account, right? So bank would ask a message that is this transaction done by you or not, because bank has found out using this anomaly detection algorithm, right? Because now humans cannot do that. Humans cannot go through lakhs of accounts and then check that is there what transaction is happening in a day, because there are number of transactions happening in a day, right? So that's not possible. So that would machine would do, right? We'll say we'll provide information to the machine that if some outlier would occur, then you would inform us, that machine would inform us, and then bank sector would give a message to a particular person, is this transaction done by you or not, just connect to the bank, right? You usually got these messages before if there is something like that. Okay, so that is spam filtering and anomaly detection, some of the example. There is one another example. Let's suppose uh, I have size of a house, and corresponding to that I have price of a house. So I have different sizes of a house, and corresponding to that I have prices of a house. So let's suppose I have a 20 lakh house and 80 lakh for different sizes of a house, right? So let's suppose if I'm taking 350 square feet, that is 20 lakh, right? Square feet. And I'm taking 1000 square feet house, that is 80 lakhs. So we have some data like that. So corresponding to that, I'll give this information to my machine, and let's suppose I just want to know that if I want to buy a house which is 700 square feet, then what would be the price of a house? I can get that from the machine. Machine can predict that for me, that what would be the price of a house if I want to buy a house which is 700 square feet. I hope that is clear. So this is one of the examples. So that's how machine learn. So what would we do? We'll provide so many information. We'll provide data to a machine, and then machine would work on the data, and then uh, it would give us this result. It would predict the result, right? There may be some error and all that. We are going to discuss that in the further lecture. Right, Keshav, that is a regression problem. Right, right, right. We'll discuss that in detail in the session. I hope this is clear. Now, next thing we have is machine learning is of three types: supervised, unsupervised, reinforcement learning. Anybody that what is supervised learning, what is unsupervised learning, and what is reinforcement learning? Just let me know. Let me know, guys. What are these type of learnings? Let me see in the chat section. Okay. Let me check my comment section. Okay. So what is supervised learning? In supervised learning, what is supervised learning? In supervised learning, we have data in which we have output and input, right? We can see that, say that in which we have label data. What does this label data mean here? Okay, some students have answered. Target data is provided for training, right, Keshav? And supervised ML is about ML that needs supervision. Okay, so let me tell you that supervised learning, in this supervised learning, we have label data. Labeled data. What does this label data means? That means, let's suppose we have taken one example, price of a house, price of a house, and we are with the help of size of a house, we are predicting price of a house. So you can see that this is my input data. That means I'll provide machine that what would be the size of a house, and it would predict what would be the price of a house, right? And we have given the data in a similar manner for the machine for the training purpose. Training purpose is that machine is training, machine is doing the training based on the training data. So size of a house, I'll provide all the sizes of a house and corresponding to that price of a house. And this is my output variable. That means I am predicting price of a house, and I am having feature that is size of a house. So this is my label data. Unsupervised learning. In unsupervised learning, we have unlabeled data. Unlabeled data means, that means, let's suppose we have a data in which we have people who go through Netflix, right? Now I have to build a recommendation system. Now I have to build a recommendation system, and I have a data which is people's data who scroll Netflix, right? Now I do not know anything about those, right? So now what would I do out of these people, right? I only have those people's data. So what would I do? Using their likeness and all that, what kind of genre they like and all those things, I would make some clusters, right? So this data is unlabeled data. We do not have any output here. Reinforcement learning is reinforcement learning in which we do not have any data. That means if we do not have any data, then we would ask that how then machine would learn, right? This would be our question, that how machine would learn if we do not have any data. Anybody in the chat section? So machine would machine learn by itself, right? Machine would work, and let's say a machine wants to play chess, right? So what would machine do? Machine would play again and again and see that at which step they are getting less points. So we'll say that for every particular step we have some points. So machine would learn that, okay, if this step would give me less number of points, so I do not have to play this again, right? That is reinforcement learning. Or we can say that self-driving cars. Self-driving cars is reinforcement learning, right? So we have three types of learning: supervised learning, in which we have labeled data; unsupervised learning, in which we have unlabeled data; and reinforcement learning, which we do not have any data, right? So supervised learning are of two types, right? Let's see this. What are these two types? Classification and regression, right? These are learn from experience, right? In reinforcement learning, we'll learn from experience, right? Anybody tell me that what would be the difference between classification and regression? First of all, they are a part of supervised learning, right, in which we have labeled data. Now in classification, we have categorical data, categorical output. I know that in label data we have input variables and we have output variable, input feature and output value. So in this we have categorical output. Categorical output. That means we are going to classify. Like we have taken the example that is spam filtering. The mail would be a spam or not spam, right? So we have only two options. That means we have a categorical output there. So classification works on categorical output. That means we are going to classify that this particular behavior is going to classify in this feature, right? Now next is regression. What is regression? That means we have numerical output. Numerical output. Numerical output. That means we are going to find out uh, output based on numerical value. Like we have taken one example, that is price of a house and size of a house. So we are predicting price of a house. Price of a house can be any real number, right? So that's why that is my numerical output that comes under regression. So we have two types of classification in two types of algorithms in supervised learning: classification and regression. Right, Keshav. Regression means numerical output. Right. Next we have is unsupervised learning, in which we have clustering and association analysis. What is this clustering means? I told you that, let's suppose I have a data of a people who scroll Netflix, right? So and I also know that what which person would like which genre and all those things, right? What kind of movies they would see, right? I know that x number of people see this movie, like this movie, and they have scrolled through it. So I have to build a recommendation system. So for that, what would I do? I'll make some clusters, right? I'll make number of clusters in my data set, so that I can recommend that, okay, certain person, a particular person like this kind of a genre, so I have to suggest this kind of a movie, right? Or let's suppose if two people are in particular cluster, right? So this person, I can see that this person is liking a particular movie, then I can suggest this movie to another person as well, which are in the same cluster. So what would I do? Using the same features, I'll make some clusters around the data, right? We are going to discuss that in detail, that how we are going to make those clusters and what would be the number of clusters I can make, because there can be possibility of number of clusters for the recommendation system. Let's suppose a person is liking uh, genre that is thriller and all those things, so there can be different possibilities for that, right? So we have to decide that how many clusters we have to make, how many clusters would give us best result, that we have to decide by ourselves. So that is my clustering algorithm. Because we do not have any label data, we do not know what is output, so what would we do? We'll see any data and we'll make clusters. If I'll take one example, let's suppose we have this data, cross, and then we have circles, right? So what clustering algorithm would do? Clustering algorithm would make clusters around this. So they would, by going through the data set, they would find out some similar features. So you can see that there are similar features, so they will make this one as a cluster and this one as a cluster, right? So that's how clustering works. I hope that is clear. Association analysis, it is the same thing. That means we are going to see that a particular person is associated, a particular data is associated with another data or not. That is my association analysis. And I already told you, when machine learns from its experience, that is reinforcement learning. That means they are going to win, they are going to play it again and again, and machine would learn that in which case the machine is winning, then they would replicate that, and it would behave differently when it is losing, so they would not use it again, in which steps the machine is losing. Keshav, yeah, I'll complete this series. Okay, so I hope this is clear, right? Different types of machine learning. So in this session, we are going to discuss supervised learning regression part, right? So let's understand this carefully. So we have discussed that supervised learning is learning a model from a labeled data in which we have input features and output value, right? So that is my supervised learning, and we have seen that supervised learning is of two types, right? Classification and regression. Whereas when we are trying to predict a real valued variable, the problem falls under category of regression, right? When we have real valued variable, real valued output, that is numerical output, then we'll say that that is my category for regression, right? When we trying to predict a categorical or nominal variable, the problem is known as classification, right? The problem is known as classification. Now we have some example. Let's decide that which one is classification and which one is regression, so that I'll know that you get it, what is regression or classification. So this example says that predicting the results of a game. So if I am predicting the result of a game, it can be either win. In supervised learning, target data is provided for training, right, Keshav? Okay, tell me guys. Yeah, predicting the result of a game. So if I am predicting the result of a game, so result, what would be the result of a game? Either win or loss. That is categorical, right? Either a person can win or person can lose. So this is my classification problem. Classification. Now next is predicting whether a tumor is malignant or benign, right? So that means we have another, again, two options, that the tumor person has is malignant or benign. Again classification, right? Next is predicting the price of domains like real estate, stocks, etc. So what it would be? Is it classification or regression? Because we are predicting the price of domains, right? We are predicting the price. Price is numerical output, right? Numerical value. Any real value is possible. So this is what? This is regression. Regression. Classifying text, such as classifying a set of emails as a spam or non-spam, that is classification. We already discussed that, right? Right, Keshav. Guys, now the main question is that you have to decide by yourself which algorithm to use in which kind of a data, right? You would, we'll discuss so many algorithms in this course, in the whole course, in your for GATE data science machine learning. So there can be question, they can give you a situation and they would ask that which algorithm would give you the best result. So you have to understand any algorithm end to end, so that you can decide that which algorithm is going to work on your data or on your problem, right? If I'm saying that spam or non-spam, I have to identify a mail, so I know that classification algorithm would work, right? So that's how you have to that's thing you have to decide. Okay, so that is supervised learning examples. Now let's discuss one important aspect, that is training and test data, because we have given so we are talking about supervised learning, we have a data and we have labeled data, right? So let's suppose I just want to train algorithm, right? So let's suppose I have 100 number of mails, let's say 1000 number of mails I have, which are identified as spam and non-spam. I already have that. Let's suppose if I'll give all those 1000 mails to a machine to learn, so that machine would learn that which mail is going to be spam or which mail is not going to non-spam. So that means they would identify some words or something like that, so that they can, if I'll give any new mail, so from these 1000 mails machine would learn, I'll give any new mail to that machine, and then I'll check that what it is giving, is it giving spam or it is giving non-spam, right? But because this is new mail, I have provided it to a machine, I do not know, I already do not know the result, right? So how do I check that machine is giving me right result or wrong result? That is a question, right? I do not know that at this position machine is giving me right result or wrong result, or what would be the accuracy of the machine, because machine is working, human also makes error, so that is a machine which you are going to train. So you have to check how much accuracy your algorithm is giving, how much accurate your machine would give you the result, right? That would be the question. So what would we do in that case? We'll divide my data into training data and test data. So the initial data which I have of 1000 mails, what would I do? I'll divide this data set. I'll divide this data set into training data and test data, right? So let's say in training data I am giving 900 emails, I'll give 100 emails in test data. So what would happen? I'll train my algorithm on this 900 emails, right? A major part I'll give to training data, so that machine would learn accurately, right? So machine would learn from this. Now what would I do in this test data? In this we have 900 emails, in which we have emails, and these emails are classifying as spam and non-spam. Spam and non-spam, it is classifying, machine is classifying, right? Machine is going to learn from these 900 emails that are or that we have already specified as spam and non-spam. Then if machine is trained, my algorithm, I have the algorithm. Now what would I do? Now I'll give these test data. Let's suppose I have this 100 points in my test data, so I'll give these 100 emails to my algorithm, to my machine. I'll give these 100 emails to my algorithm and see that what they are predicting. So for those 100 emails, machine would classify that they are spam or not spam, and I already know the result because this is my initial data. These 1000 points are my initial data. I also know the result for 100 points. So what would I do? I'll check that my machine is predicting one result. Let's suppose y cap is a result my machine is predicting, and y is a result I know that is already correct, right? Correct result I have, and y cap is the result my machine is predicting. Then I'll see the difference between that. So that would give me the accuracy. That difference is that difference will give me the accuracy, right? And this accuracy, if this difference is large, right, it is giving wrong results for number of let's say if it is giving out of these 100 points, the machine is giving 60 points wrong results. So what does it mean? That means we have 40% accuracy. That is not a correct algorithm, right? So that's why I'll not use that. I'll again go to my algorithm and make some changes, because I need correct accuracy, right? I need my model to be accurate, so that I'll get good accuracy, I'll get good results or right results, I can say that. So what would I do? I'll train my data, I'll work on my algorithm and see that my whole algorithm would work well, so that I can get accuracy around 80%, 80% or above that, right? So that's why test data is required, which help me to know that my machine is working properly or machine is giving me right results or not. Because if I do not give test data, then I do not have the option to check that how my machine is performing, right? So the first split of data, that is initial reserve of data you use to develop your model, provides the training data, right? We call that as a training data. After you have successfully developed a model based on the training data, and are satisfied with its accuracy, you can test the model on the remaining data. So you would test the model on the remaining data known as test data. So I hope that is clear. Just let me know guys if there is any confusion between test data and training data. Just let me know. Okay. So that is my basically working on any supervised learning model. What would we do? We'll have label training data. So we have some, let's suppose we have 1,000 number of input data, right? 1,000 number of 1,000 points in my data. What would I do? I'll use my training data. Out of this training data, I'll use only 900 points, right? Then I'll work on my algorithm, develop my model. Then it would go to the prediction model, right? That means it would predict, I'll get some results based on that, that would predict uh, any output for the data, right? Then what would I do? Provide my I'll provide the test data to the algorithm to check that how much accuracy I am getting, how much my algorithm is working properly or not, right? I'll check that. And then later on, if it passed the test data, if I'll get good results from the test data, then I'll use it for prediction, right? So that's the working behind the supervised learning model. Okay, I hope it is clear. Now let's move further. Regression, right? So regression, we already have discussed that what is happening in regression. We have some input variable. Let's suppose we have some input variable x, corresponding to that we are predicting y. Let's take one example. Let's suppose we have size of a house, size of a house, and we are predicting price of a house corresponding to that, price of a house. And we have some initial data. Let's suppose we have hundreds of data in my data set, and I have to predict any another for any particular size, that what would be the price of a house in a particular uh, what would be the price of a house for that particular size of a house, if I want to predict that. So how does regression work? Now this is a question. So basically, because this is x and y variable, we have 2D data, we have input variable, we have output variable, and output variable is also numerical, input variable is also numerical, right? So what would I do? i'll I'll plot this data on my 2D space. So let's suppose this is my data, right? This is my data, right? So what would I do? Because you can see that this is 2D data and it is numerical, I want a best fit line here, right? I want to plot a best fit line. Best fit line, that means which fits the line, which fits my data properly, right? So what would I do? Because there can be any line possible, any line possible. So my data would work as y is equals to m into x plus b. This is equation of a line. Y is equals to mx plus b. So that means you can see that, let's suppose I am saying that this line predicts my data properly, right? This is my line which predicts my data properly. I'll take this as my algorithm. So what would happen here? So let's suppose I want to know that at this price, at this particular price, here in on the x-axis we have price of a house, sorry, on this x-axis we have size of a house, size of a house. On this axis we have price of a house. If I want to know that at this particular size what would be the price of a house, I'll go to that line and see that at this particular price, that would be at this particular size, this is the price of a house. So I got the result. So now you can see that for any size I can find out a result if I'll get a best fit line. Best fit line means that my data, um, this line fits my data properly. That is my best fit line. So for that my equation would be y is equals to mx plus b. I can write down, because this is a predict. So x is my input variable, y is my output variable. So I'll use y cap notation, y hat notation for y cap is equals to m into x plus b, or because I have written here wx, so let me write down w into x plus b, right? Y cap is equals to wx plus b. So I hope this is clear, that why we have taken wx plus b, why we are taking a line here, right? So y cap is equals to wx plus b. I am taking a line. But now how would I decide what would be the line? X is given, y is given, right? I have input data, I have output data, I have all those things. What would I do not have here? I do not have here this w, I do not have this b value. So I have to decide that which w and b would I would take, so that my line fits properly to this data set. Right? This is a question. So can anybody tell me that how would I decide that what would be the value of W and B? Okay, so let's see. So we have seen that, let's suppose I take any random line. Let's suppose I am taking this line. Like this is one of the random line. So now what would I do? I'll check here, because you can see that at this particular price, at this particular size of a house, I am getting price of a house, this one. But according to this line, price of a house would be like this, right? So there is a difference. This, what this value would call, let me draw it again properly. Let's take this. Let's take this point. If I'll take this point, now let's see. If I'll take this particular size of a house, x naught, let's say this is my x1. So we know that what would be the price of a house? Price of a house would be this y1, right? Based on the given data, because we have given a certain point here. So that means uh, at this particular point, because we have given this already in my data set, we are getting this y1 price. But if I'll go through this line, but if I'll go through the line, I'll check, this is why this is my best fit line. That means this line fits my data. So I'll check that at this particular position, right? This one, my price of a house would be this y1 cap. Y1 cap is predicted value. For this size of a house, x1 size of a house, my actual value is y1, my predicted value is y1 cap. So there is a difference between these values, right? There is some error, right? This line giving me some error. And what I want to do with this machine learning model, I want to minimize this error, right? What would happen if I'll minimize this error? Because I because if, let's suppose this is my data, if I'll try to fit a line, then this line do not give correct result, exact result for each of the value, right? This line cannot fit each of the value. So that what would I do? I'll minimize this error combinedly for all of the value. That means I have to for x1 value, I have to minimize this output value, these two output value, predicted and uh, actual value. For each of the point I have to do that. So what would I do? I'll define one cost function here, cost function, or I can say that loss function, right? It's up to you. Cost function or loss function, it is what? Y minus y cap. Now because y minus y cap, and it is for all of the points, right? Let's suppose we have n number of points in my data set, so I have to minimize this error for each of the point. So can I write down yi minus yi cap summation I varying from 1 to n? So I have to minimize this error. But one thing you can see here, that uh, if I am getting y1 minus y1 cap, here I am getting this as a negative value. But if I'll take these points would give me positive value, right? Let's suppose we have some what I mean here is, let's suppose we will take any point here, right? So we have yk value here, but yk cap would be this one. This is what? This is yk cap. Now yk cap is less than yk. So this value would be, what would happen, this value is negative for uh, this value is negative for y1 and positive for yk. So now errors get cancelled out because of positive and negative. So for that, because of that, I'll take a square here, right? That's why I'm taking a square in the cost function. And because of some differentiation, we know that to find out maxima or minima, we have to use differentiation, right? I hope you already know that, right? For differentiation and integration, we are going to use, sorry, for minimizing or maximizing, because we, what we have to do, we have to minimize this error, right? So that means we have to minimize this value, and because of that, I am taking 1 by 2 here, because when I'll differentiate, 2 would come in front. I do not want that, so that's why I have multiplied it with 1 by 2, right? So this is my cost function, 1 by 2 summation I varying from 1 to n yi minus yi cap square, right? So what is yi is the actual value, yi cap. What is yi cap? Yi cap would be wxi plus b, right? That is my yi cap. So let's write it down here. What is yi cap? Okay, let's write it down here. That means 1 by 2 summation I varying from 1 to n yi minus wxi plus b ka whole square. I have to minimize this, right? I have to minimize this. I have, let's say I am writing here jw comma b. This is a function for w comma b, because yi and xi are the known values. Just let me know, guys. We have to minimize this jwb. This is a function of w and b, and we have to minimize this jwb. What our main goal is here? Main goal is minimize jw comma b, and we have to find out values for w and b. We have to find out values for w and b. So w and b will give me the best fit line, right? That means this line can rotate at any place, right? And w and b will fix my line. So that means I want to find that line which fits my data properly, and that I'll decide by w comma b. And how do I find out w comma b? To minimize the error in a, so I'll take any random line and I'll try to minimize that by minimizing this error. Okay, yeah, we can take it 1 by 2n, because summation I varying from 1 to n. Okay, so that's how our minimization works. Just let me know, guys, is there any confusion? Yeah, this is if anybody have studied, this is one of the method which we used in least square in statistic, right? Least square do the same. What we are doing, we are finding out least value for this square. Okay, so that's how regression works. Okay, so we have this example here. You can see that we have given some age in years and we have given some blood pressure, right, corresponding to the age, right? This is the data I have given. Blood pressure is a dependent variable, uh, and age is my independent variable. X, that is my input variable, that is my output variable, right? I want to find out a best fit line here. I want to find out a best fit line in this data set, so that I can predict that at particular age what would be the blood pressure, right? In a particular age, what would be the blood pressure? I want to know that. So for that, what would I do? I'll specify one model, right? I want any particular line here, right? Regression uses line to show the trend of a distribution. There can be many lines that try to fit the data points in scatter diagram. Here my aim is to find out a best fit line, right? I have to find out a best fit line. So how would I find out a best fit line? Best fit line tries to explain the variance in a given data or minimize the total residual error. So I already told you what is this total residual error? That is cost function, right? I have to minimize that cost function. I already told you all those things. I hope that is clear. Now, model is y is equals to w naught plus w1x, right? You can define mx plus b or wx plus b, it's up to you. So we have to find out, estimate the value of w naught and W1, right? That is our goal. We have to minimize the value of W0 and Wn. You can write down here 2n as well. So it's up to you if you want to write down 1 by 2 or not. It's up to you. So this is what yi minus y cap y hat square and yi minus W0 W1 xi square. That is my model. Just let me know, right? Guys, in this cost function, anybody have any problem? I can write down here j W0 comma W1. And my goal is to find out W0 comma W1 so that I'll get a best fit line here. Right? Just let me know, guys. Is there any confusion? We'll see that how to minimize this so that I'll get best value for W0 and W1. We have to understand this algorithm. Guys, if I want to code, I have direct algorithms, I have direct code so that I can get the results. But I have to understand that how my machine work here to get the results, right? So for a gate exam, we have to do that, right? Let's see further. Multiple, okay, so we'll see that how we are going to minimize that. But before that, I just want to tell you about multiple regression. Guys, we have seen that corresponding to a particular size of a house, we are predicting price of a house, right? But there may be a possibility that we can get certain number of input features, right? There can be many input features. Let's suppose we have size of a house, one feature, and another feature we have number of rooms in a house, and number of floors in a particular house, number of floors it is covering. So if we have all these input features and then we are predicting price of a house, that means we have feature x1, x2, x3, and we are predicting output price of house, right? Then what would we do? Anybody? Then what would we do, guys, if I have this condition? Again, I am going to use regression because we have a numerical output. So what would we do for here? I'll write down my model y cap model. Up to now I was writing model wx plus b. I have written down a model. When we have one initial feature, I have written wx plus b. I was talking about a line. But here, because we have number of features here, I'll write down a plane. W1 x1 plus W2 x2 plus W3 x3 and plus b. That is my predicted price. Again, I have to do the same thing. Now, because to find out this plane, to find out this, to minimize the error, what I have to find out? I have, in previous case, when we have single linear regression, we have simple linear regression, I have to minimize, I have to find out a value for W and B such that I have this y minus y cap minimized. Right here, I have to find out W1, W2, W3 and B, because x1, x2, x3 I already have predicted value. I have to find out, and predicted value I can find out using initial features, right? So what would I do? I'll again write down y cap minus y whole square 1 by 2 n summation yi minus yi cap square I varying from 1 to n cost function j. Now the function would become for what values? W1, W2, W3 and B, right? Because now the function is yi cap. Okay, let's take it similar to what we have done previously. So yi remains same minus W1 xi x1 plus W2 x2 x1i, x2i, W3, x3i, right? Why I am writing x3i? That means for the third feature I am taking ith value, right? For second feature I am taking ith value. That's why I have taken here x3i, and plus b whole square, and yeah, whole square, and 1 by summation I varying from 1 to n 1 by 2n, right? So this is my cost function. Instead of finding out two variables which I have found, which I want to find out previously. Here I have to find out four variables because I have three features. When I have one feature, I have only when I have one feature, I have used only I have to find out only two variables, two values. Here I have to find out four values because I have three input features, right? But this is literally getting complex. So what would I do? I can use vectors here. So if I write down, can I write down this as w1, w2, w3, and I can write down this as x1, x2, x3 plus b. So can I write down w vector into x transpose, w dot x transpose plus b, and this is also b, right? This is my b value, right? So you can write down this y cap as w dot x transpose plus b. This is what, this is dot product, right? Here we have the vectors. Rajiv, can you tell me that at which step you are having problems, and have you joined the session from the starting? Guys, let me know if anybody else is having this confusion. So that's how I have. Now here I have to find out w1, w2, w3 and b. This is one of the notation. This is one of the notation for multiple regression. Okay, Rajiv, because you have joined right now, so that's why you are not understanding. After this session, just go through this lecture from the start, then you would understand that what we are doing previously. Just if you do not get that later, then you can post that in the comment section, right? I'll get back to you. But right now, because you have joined the session in the middle, and we have covered linear regression, simple linear regression. That's why that is a multiple regression is a uh, uh, is extension of what we have studied in simple regression. That's why you are having this confusion. Okay, so there's not much of the maths we have used right now, because what we have done, we in the simple linear regression, let's see, in simple linear regression what we have done, we just have find out a line. What is the equation of a line? In this case, what is the equation of a line? That is simple. Y is equals to mx plus b is the equation of line. And guys, you have to clear some basic concepts. You have to clear your some basic concepts in mathematics to work on machine learning. That's why at the start of your GATE data science syllabus, you have three subjects which are from mathematics, right? So you have to work on some of the calculus, that what is equation of a line, how differentiation would work, how integration would work, how we'll find out maximum value, how will we find out minimum value. You have to go through all of these things, right? So guys, from the next session, just go through the basics of mathematics, right? Then you would understand what is the prerequisite for this session. Okay guys, let me tell you what are the things you have to uh okay what are the things you have to go through, you have to go through before the machine learning syllabus. So just go through the basic calculus. So first you have to work on line and equation of a line, equation of line, planes, right? All those things, that is one of the important thing. And then you have to go through uh, differentiation, differentiation and also integration, partial differentiation as well. Just go through the basics of these topics, then it would get clear more, right? Partial differentiation, and also you have some basic idea about maxima and minima. We can say that optimization as well, maxima and minima, right? Just go through these basic concepts. right? These are the topics in engineering mathematics. Okay, I'll playlist. Okay. Okay, it's just go through the link, just go type the topic and go through these any of the video, you would understand, because these are some basic topics. uh, Otherwise I'll suggest the playlist in the before the next session, because I haven't go through these in video, so I don't remember right now, but I'll suggest in the next session. Otherwise, if you have to study these topics are really basic. Just like write down equation of a line and any video would work. Okay. So guys, just go through these concepts and just work on what we have studied in simple regression and multiple linear regression. Simple linear regression and multiple linear regression, we are going to get in detail how we are going to minimize the cost function in the next session, because it would require to find out minimum value. I'll discuss it from the scratch, right? But before that, just go through these topics, right? Then you would understand better, right? Next session will be tomorrow on at 5 p.m. Okay, just let me know guys if there is any another question. I am stopping it right now because I just want that student would once go through these topics first, just go through the basics of these topics, basic understanding is required, then I'll move further. Otherwise, just let me know in tomorrow's session. I'll first go through these concepts first, and then I'll move to another topic. Just let me know guys, I'll go through these basics. And just uh, Rajiv, if you haven't seen this complete session, just go through this complete session and let me know in tomorrow's session that if you guys have any confusion. How long will the lectures will be? I think 1 hour, 1 hour, or it would extend up to 1 hour 15 minutes, up to that. That would be the length of the lectures. Okay, so that's all from my side, guys. If there is any question, please ask. Otherwise, we'll continue in the next session, which will be tomorrow. Okay, so guys, I'll once go through these topics first, but I'll give only the basic idea. You just have to go through in detail by yourself. I'll give the basic idea. Otherwise, we'll be very behind before to cover machine learning topic, which I am here for. Okay, sure, guys. I'll go through these mathematics lecture, and then so I think tomorrow lecture I have to rename the topic, that is maths behind machine learning. Okay, then we'll start further. Sure, guys. Okay, thank you guys, thank you so much for joining.